Assalamualaikum and hello everyone. In this video, we will learn about binomial distribution. Binomial distribution is a part of probability distribution that is in related with discrete random variables. For random variable, we have covered in our last class. For this class, we will continue about binomial distribution. So let's first look at Bernoulli's trial. Okay, in binomial distribution is always related with Bernoulli's trial, which is there are only two outcomes, namely success or failure. In Bernoulli's trial, we will only consider two outcomes, which is success or failure. So the success is the outcome for success is depend on what we want to what we want to know, and the failure is the opposite for success. Okay, the chance of success are always the same in every trial. Okay, in discrete random variable, we have learned about how how an event happen for if we have multiple trial. Okay, multiple trial, which means for example, if we toss a coin, okay, multiple times, for the first toss, there should be only two outcome, which is head or tail. So in Bernoulli's trial, we will consider is either if we want a head, we can consider getting a head is a success, while getting a tail is failure. Okay, if we throw multiple times for every trial, the chance of success are always the same, which is 1/2 for a coin. If we throw a dice, it will be 1/6. Alright, so the chance of success are always the same in every trial. So it is independent. Okay, if the probability of success is given by P, then the probability of failure is given by 1 minus P, where P is in between 0 to 1. Okay, it cannot be less than 0 and greater than 1, because the probability distribution for all event, the maximum is 1. Okay, so the failure is 1 minus P. Okay, so the discrete random variable x is equal to 0 and 1, where 0 represent the failure and 1 represent the success. Okay, alright, so the probability for event for binomial distribution is using the Bernoulli's trial. Okay, so we get a formula for binomial distribution, which is P x equal to R is equal to NC R P power of R Q N minus R. So what is all these unknown stand for? So N is the number of trials, R is the number of success, P is the probability of success, and Q is the probability of failure. Let's say we have a coin. Okay, so we need to know the probability. If we toss 3 times, okay, what is the probability of getting 2 heads? So our success should be getting a head. So n is the number of trial, which is if we toss 3 times, the number of trial is 3. Okay, if we want to know the probability of getting 2 heads, okay, so the number of success must be is equal to 2. Okay, because we want to know if we get 2 times head. Okay, the probability of success should be, if we toss a fair coin, it should be 1/2. Okay, and the probability of failure is also 1/2, because 1 minus 1/2, we get 1/2. Okay, that is example. Okay, so let's look at a real example in this situation. Okay, so the example stated that 1/4 of the eggs in a basket are rotten. If 2 eggs are chosen at random, find the probability that A, both eggs are rotten. B, only one egg is rotten. Okay, so the probability of getting a rotten eggs is 1 over 4. Okay, if we pick 2 eggs, which means the number of trial is 2. Okay, find the probability that both eggs are rotten. Okay, so the probability of success. Okay, the success in this case is getting a rotten egg. Sebab kita nak tahu probability kita dapat dua-dua telur busuk lah, rotten egg. Okay. So P is the probability of getting rotten eggs, which is 1 over 4. So 1 over 4, if we convert into decimal point, we get 0.25. Okay. While Q is not getting rotten egg. Q is the probability of failure. Okay, so failure is 1 minus 0.25, which is 0.75. Alright, so if we want to know the probability of getting both eggs are rotten, okay, which means the number of success is 2, while the number of trial is also 2 because we pick 2 eggs. Okay, so the formula for probability binomial distribution is NCR P power of R Q power of N minus R. Okay, in this case, your N should be 2 and R is also 2 because the number of success should be 2. Okay, so P is probability of success, which is 0.25 power of R, which is 2 here. Okay, and times 0.5 power of N minus R. So N minus R is 2 minus 2, which is here we get 0. Okay, so then you calculate using your calculator, you will get the answer is 0.0625. Okay, this is the probability of getting both eggs are rotten. Okay, if we want to calculate if the probability for only one x is rotten, okay, so we need to change. It's not x equal to 2, but it is x equal to 1 because only one. Okay, n is the number of trial, which is 2. R success is 1. So you can refer R with this number here. Okay, and 0.25 power of R, 0.25 power of 1, 0.75 power of N minus R, which is 2 minus 1 equal to 1. Okay, then calculate, you will get the probability is 0.375. That is how you use the formula for binomial distribution. So in binomial distribution, actually, if we relate with the discrete random variables, okay, we will calculate the probability for only countable things. Okay, in this case, eggs are countable. We can count eggs for 0, 1, 2, 3, 4, and so on. Okay, so in this binomial distribution, it only applies to countable data. Okay. Alright, next example. In a certain village, the probability that rain falling on any day is 1 over 3. If 3 consecutive days are taken, find the probability that it will rain for 2 days. Okay, 2 hari hujan. Okay, the sample is 3 because it says that 3 consecutive days are taken. Okay, so here the probability of success is that the probability of raining, and the failure is not raining. So probability for rain falling is 1 over 3, and not raining 1 minus 1 over 3, which is 2 over 3. Okay, and then let's calculate the probability that it will rain for 2 days. Okay, so probability for x equal to 2, which is 3C2. So 3 is your n, okay, number of trial. 2 is the number of success. Here we refer with how many days it rained. Okay, and P is 1 over 3 power of 2, 2 over 3 power of 1. Okay, you should know by this time. Okay, so calculate, you will get the answer is 2 over 9. Alright, next, B, it will rain at least one day. Okay, at least one day, which means it's either 1 day, 2 days, or 3 days. Okay, we have 3 different case here. Okay, so it's either 1, 2, or 3. So we need to calculate for every case. Okay, if the probability for one day raining, okay, px equal to 1 plus px equal to 2 plus px equal to 3. So we need to consider all the possible outcomes. Okay, so for px equal to 1, which is 3c1 1 over 3 power of 1 times 2 over 3 power of 2 plus this one is equal to this one above. Okay, 3c2 times 1 over 3 power of 2 times 2 over 3 power of 1 plus 3c3 1 over 3 power of 3 and times 2 over 3 power of 0. Okay, so this is all the case you need to add. Okay, you need to find the total for all the probability here. Okay, you will get 19 over 27. Okay, mind that the sentence here, at least. Okay, at least, which means at least one day is raining. Okay, alright. So this is an exercise for you. I hope that you can try this exercise by yourself. And I will share the answer in our group. Okay. And this is also another exercise. Okay. Next, we will continue into table and graph of probability distribution for discrete random variables. Okay. So for discrete random variable is a binomial distribution. So for this table and graph, it's we have covered in our previous class in random variable, which is discrete random variable. We have learned how to represent the data using table and graph. Okay, so I use the same example. 70% from Form 5 Dahlia students achieve a grade A in final year examination for science subject. 2 students are chosen at random from that class. If X represents the number of students who did not get grade A, construct a table to show all possible values of X. Next, draw a graph to show probability distribution of X. Okay, so 2 students are chosen at random, which means that we have two trial. Okay, number of trial is equal to 2, which is your n is equal to 2. Okay, and then so we need to represent using table. So we need to calculate the probability one by one. Okay, this one, your success should be 0.3. Okay, who did not achieve grade A, and your failure should be 0.7. Okay, so you will calculate one by one and then you represent it using table. Okay, for 0, 1, 2, the maximum is 2 because the number of trial is 2. Okay, and then you represent using table. Okay, which is here you can see the table should be, sorry, the graph should be not connected with each other. Okay, because this is discrete random variable. Alright. Okay, then how do we interpret the information from the graph? Okay, this is very important because the graph shows the probability for each possible outcome of X. Okay, let's say the diagram, let's say we have this diagram. Okay, it shows the binomial distribution graph. State all the possible values of X. Okay, the value of X is the number of success, the number of possible, the number of the possible number of success. Okay, which is if we have the maximum number is 4 because we have maximum 4 trials. Okay, so the maximum the probability of success which is either 0, 1, 2, 3 or 4. It's either no success or 1 success, 2 success, 3 success or 4 success. Okay, so the possible outcome of X is 0, 1, 2, 3 and 4. Okay. Okay, this is the possible outcome of X. And then find the value of N. Okay, this is very important because if the graph shows that the probability against the success rate, the number of success, okay, so which means, like I said just now, okay, the total probability is equal to 1, which means if you add the value of probability for all trial and all number of success, you will get equal to 1. Okay, which means if we add px equal to 0 plus px equal to 1 plus px equal to 2 plus px equal to 3 plus px equal to 4, you will get equal to 1. Okay, and then you just use this value here. Okay, for px equal to 0 is 1 over 16. For px equal to 1, you will get n. For px equal to 2, you will get 5 over 16. For px equal to 3, you will get n. And for px equal to 4, you will get 1 over 2n. So you just add all the value here. Okay, and find the value of n, which is equal to 1 over 4. Okay, for another example, okay, so we have a graph, okay, binomial distribution graph, px equal to r, probability against the number of success here. Okay, state all possible value of x. Kita tengok kat sini je lah. Okay, just take the value from here, 0, 1, 2, 3, 4 and 5. Okay, so that is the possible value of x. Okay, and then find the value of m from the graph. Okay, like just now, we just add all the value for every number of success. Okay, and equal with 1. Okay, so 1 over 4m plus 1 over 9 plus m plus 2m plus 5 over 36 plus 1 over 36, which is equal to 1. And then you just have to find the value of m here. So you will get m is equal to 2 over 9. Okay, and then C, find the percentage for px greater than or equal to 2. So P lebih besar atau sama dengan 2. So we need to consider the number of success here should be 2, 3, 4 and 5. Okay, greater than or equal. So just add all the value here. Okay, m, 2m, 5 over 36 and 1 over 36. Okay, but okay, we substitute the value of m. Okay, which is 2 over 9. Okay, if you will calculate, you will get it is equal to 5 over 6. Okay, and convert into percentage, you will multiply with 100. So you will get the answer is 83.33%. Okay, actually this one should be 2 over 9. Okay, this one is 2 over 9. Okay. And then in binomial distribution, there are also the value of mean, variance, and standard deviation. Because if we do a lot of trials, okay, we need to find the mean, which is the average, okay, variance, and standard deviation. For all trial, variance and standard deviation shows the dispersion, okay, the dispersion for the data. Okay, if we make a lot of trial, okay, so we need to consider these three values, okay, which is mean, you can calculate the average, okay, average of the trial, variance and standard deviation for dispersion. Okay, so the formula for mean is mu equal to np, where n is the number of trial and p is the probability of success. So the variance is sigma square, which is equal to NPQ. So N number of trial, P is probability of success, Q is probability of failure. For standard deviation, you just square root from the variance. Okay, let's look at an example. A study shows that 95% of Malaysians aged 20 and above have a driving license. If 160 people are randomly selected from this age group, estimate the number of Malaysians aged 20 and above who have a driving license. Then find the variance and standard deviation of the distribution. Okay, so if we look at the example here, 95% have driving license. Okay, if we want to find the probability, okay, we need to find the probability for the Malaysian who have driving license. So the probability of success should be 95%, which is 0.95. Okay, and the probability for failure is 1 minus 0.95, which is 0.05. So if 160 people are randomly selected, which means we choose 160 people. Just now, before in previous example, we just choose around 2, 3, or 4 or 5. Okay, this one is 160 people. So if we do a lot of trial, okay, then we have to calculate the mean. Okay, estimate the number of nation. If the question said estimate the number of Malaysian age 20 and above, which means we need to calculate the mean for the number of nation who have a driving license. Okay, so using the formula mu equal to NP, okay, where N is your number of trial, which is 160, and the probability of success is 0.95. Okay, and just multiply these two, you will get the mean is 152, which means the estimate number of students who have driving, the estimate number of Malaysian who have driving license from 160 people is 152. Okay, if we choose 160 people, roughly from 160 people, ada 152 people who have driving license. Okay, for the rest it doesn't have lah. Okay, and the variance variance is sigma squared is equal to NPQ. Okay, you just multiply 160 with 0.95 and 0.05, you will get 7.60. So this is the variance, and the standard deviation is just square root 7.6, you will get 2.76. Okay, this is how you calculate the mean, variance, and standard deviation from binomial distribution. Okay, next example. In a village, the probability of raining in a certain day is 0.2. A survey is carried out for 60 days. Find the mean. Okay, the mean should be 60 times 0.2. Okay, and then the variance is 60 times 0.2 times 0.8, you will get 9.6. And the standard deviation, you just square root from the variance, you will get 3.098. Okay, around 12 days will be it will be raining. Okay, all right. So in binomial distribution, okay, from the formula mean equal to NP, standard deviation equal to square root of NPQ. So there are many different ways to solve a problem. Okay, such as this example, a discrete random variable x has a binomial distribution which is x b in bracket NP with a mean of 45 and a standard deviation of 3. Find the value of n and p. Okay, so if mean is equal to NP, which is 45 equal to NP. In this example, we have the value of mean and standard deviation, but we doesn't have the value of number of trials and the probability of success. Okay, so we need to find the value of n and p. Okay, so we make n into a subject, so we'll get 45 over p. Okay, and for standard deviation is square root of npq. You will get, since q is equal to 1 minus p, okay, so we just substitute this value, okay, and then solve the square root. Okay, we square the 3, you will get 9, and p equal times 1 minus p. So you can substitute the value of n into this equation. This is actually simultaneous equation. Okay, so substitute the value of n in term of p. So you can solve p, okay, which is p is equal to 4 over 5, which is 0.8. Okay, when you have found the value of p, okay, you can find the value of n, which is 45 over p. So 45 over 0.8, you will get 56.25. Okay, but since the number of trials should be in integer, because in binomial distribution we we relate with the discrete random variable. So in discrete random variable, it should be countable. Okay, if it's countable, it should be integer. Okay, so we will just bundarkan dia. Okay, round off into 56. Actually, it's not round off because if the value 56.25, the value for 0.25 does not count. Okay, the value for the decimal doesn't count because there should be uh, no half people or half person or half animal or half things. Okay, so we just take the value 56. Okay. Alright, so this is the exercise for you. So I hope you can do this exercise. If you have any problem, okay, you can discuss in our group. Okay, for today's video, we will end here, and for the next video, we will continue about normal distribution. Okay, so that's all. Thank you.